All right, time for another DraftPhysics.com, DebatePhysics.com also, but the debate is just troll responses to trollish, content. Just almost engineered statements that are just to put somebody on the defensive, oblige them to make explanations that are irrelevant, just mush. So anyway, Piero. So the best he can do is a response to all these arguments like, do you believe levers conserve momentum? Not a very difficult question. Now, clearly, if you say yes, then you have to concede kinetic energy is garbage. And if you say no, then you have to say, gee, physics has been saying stuff for a long time that just isn't true. Momentum is meaningless because you don't have to conserve it. Yeah. The only proof you'll accept that someone is a truth seeker. So when did the subject become truth seeking, whatever the fuck that is? But I would just argue it's innate to all conversation is the assumption that you're arguing about the straightness of a line, about the correctness of a statement. Whether you call it truth seeking or fact finding or some other jargon, who cares? And each one of the subjects is, in fact, an individual subject. You could argue wave particle is a separate subject from black hole singularity. That these don't have to be, it doesn't have to always exclusively be about some universal theory. It just has to be about arguments about what is a reasonable speculation regarding definition of a truth. And this is just evasion, whatever this is. As if they agreed with you at the current moment. All right, so I'm going to prove you'll accept that someone is a truth seeker if they agree with you at the current moment. No, they have to answer questions, and the answers have to be consistent. They can't say momentum is conserved and then say momentum isn't conserved under my special circumstances. I mean, there has to be some consistency somewhere. All right. Let's see. At the current state of your theory. So again, implying that my theory has somehow dramatically changed when no, it really hasn't. Okay, it's always been a particle momentum theory, and it's never been a wooey, phantasmagorical, fake, phony fantasy which you are defending. So, whatever. Is there something else to say? I mean, clearly, it's you could argue it's concept against mathematics. I mean, I could use the jargon of other people, mathematicians, and it's just voodoo. But it's really not that the math is wrong. That doing math is wrong, or that approach is wrong. It's just that the formulas are clearly wrong. MGH is clearly wrong. MGT is the cause. All right. Work equals force times displacement. No, it's force times the amount of time you're applying the force. So again, just so obvious that you just have misdefined the fundamental axiom formulas. 4 pounds dropped 1 foot is not the same impact force as 1 pound dropped 4 feet. It's not true. So you've broken reality by, these draconian assertions you make. Water waves don't behave the same as light waves. These are just facts, and you ignore them. Where's the other guy's comment? You mean he took it down? Damn. Well, that's irritating. All right, so what do I do about that? All right, well, I'll see if I can try to remember it. Or find a copy of it. Yeah, that's it. Well, I actually do have a copy of it, so surprise, surprise. I have to open videos in a private window to see them, right? Because of YouTube playing games with attacking my account, which must be an IP account because the other computer isn't signed in, and it doesn't let me watch videos either. So it's obviously an IP attack, but it's just so strange. Anyway. I mean, they'd go to this trouble to prevent me from, commenting on somebody's video. That I've been blocked by actual YouTube. Yeah, just too ridiculous. I mean, yes, it's too ridiculous. Yes, it's too ridiculous. All right. So this channel 321 guy. Sorry for invading your comment section again, but I will stay on the subject. So in one of your recent videos, you said Huygens didn't say that you can create free momentum or quantity of motion, but here's what he said. So again, you want to argue that Newton and Huygens believed you could make free momentum. I'm just going to argue I don't think so, because they would have noticed that and they would have pointed it out. So it really doesn't matter what you're doing with this jargon, okay, frankly. I don't know what language Huygens published in originally. I mean, maybe this is all because, nobody can properly interpret Latin. I don't know. But, so we just go through the experiments. Now, clearly Descartes said things, in general terms where, it only happens 80% of the time, and he's implying it always happens. You could argue that Newton's third law is broken in the sense that, yes, some collisions, some events, firing a gun, that's an equal and opposite reaction, right? Okay, the explosion goes in both directions. Now, you don't believe it's equal and opposite because you think the bullet got 2,000 joules of energy and the gun only got 2. But that's what Newton's talking about, is that many of the events that happen, the energy events in the universe, have this symmetry to them. Spherical symmetry, actually. Okay, the ones that are related to energy in the universe are often expansions. Something expands or something contracts, and so that's easily understood as proportional. But the trick is there's these events where, no, somebody just hits somebody else and gives them part of their momentum. This one's moving, it hits something else, now it's moving half the speed, and something else is moving the other half of its speed. So clearly there is no equal and opposite reaction. There's just the action of it losing part of its momentum. So you could argue about a lot of these are statements not being purely precise. So I guess if I have to side one way or the other, if we're going to be so exacting that we're going to just ignore 90% of the cases and just say the 10% are more important, that's fine. I'll say that, okay, I disagree with both Huygens and Newton because this doesn't happen. And I can give you examples where it obviously doesn't happen. The quantity of motion that two hard bodies have may be increased or diminished by their collision. Now, they didn't say hard bodies of uneven masses. So that's all qualification, right? It matters. If they have the same mass, then the rule holds. If they have a different mass, the rule doesn't hold. So that's sort of important. But when the quantity of motion in the opposite direction has been subtracted, there remains always the same quantity of motion in the same direction. So if a one mass and a one mass is moving and another mass is moving faster and it hits, well, the first mass will move faster and this one will move the speed it was moving. So they'll just exchange their momentums. And still the extra is still the only extra exists. And you could argue if they equal masses and they collide, the same thing happens. So the rule holds for bodies that have the same mass. All right, but it doesn't hold for ones that don't. So in that quote, we're not clear that he's talking about any weighted object hitting any other weighted object. All right. And then he quotes Newton. And then this quote by Newton saying the same thing. By the congress and collision of bodies, the quantity of motion collected from the sum of the motions directed towards the same way or from the difference of those that were directed towards contrary ways was never changed. So the simple example is, the 150 car crash into the 50 car. One's going 50 this way, one's going, let's say, 150 that way. Certainly we're not conserving that quantity. Now you can say, okay, well, we conserve the 100 difference, right? but then I just make the simple example. So, let's see. I think I can draw that. We'll try the new drawing system for fun. I don't know if it'd be fun, but we're going to try it anyway. I'd like to migrate to this kind of thing so I don't have to worry about all the dry erase crap. Alright, so you have one object moving 50 in this direction, and you have another object going 150. Alright, so let me just change the scenario to make it impossible for you to, do your thing that says Newton couldn't figure this out. So you're saying these two things collide, okay? And I don't conserve the total momentum, but I conserve this little 50, the 100 part, okay? 50 subtracted from 50 leaves me 100 going this way. So I end up with a small object going 100 and the big object being dead. All right, so what if I just change the scenario, make this 1 million, okay, miles per hour, and I make this one, going this way, right? And the other one's going 1,050,000. Okay, now you could sort of understand that you don't think Newton thought that something could hit something 1 million miles an hour going this way, and something else is going 1 million miles an hour this way, and they collide, and only 50 momentums, 1 million momentums versus 1,050,000, and only 50 pops out. Now, you don't think Newton was that stupid, do you? What do you think Newton would say? If I propose that to Newton, what do you think Newton would say? That, yes, 2 million units of momentum disappear from the universe, and all you're left with is 50. And we're talking about elastic. All right, So we're talking about somewhere where we have to see the motion come out of the experiment. No crushing, no heat, no nonsense. So where did the 2 million units of momentum go? Because your theory is only 50 pops out. And you're saying that Newton thought only 50 would pop out. So I'm just saying to you, do you really think Newton believed that? And I'm saying, of course, Newton didn't believe that. So whatever you're quoting here lacks some depth, because it's so easy to create a scenario where Huygens wouldn't say, oh yeah, just 50 pops out. I don't think Huygens thought so. So, it seems you're stretching the truth. I wish this just focused a little better, contrast was better, but I just can't. It won't quite do that for me, which is really irritating. But a lot of things are really irritating. Yeah, well, try a little more light, but doesn't really change it much. Anyway, I have to work on it. Just wish it would just work, and then I would just be able to do it now. I wouldn't have to fiddle with this. Fiddling with the lighting. Too much light doesn't work. If I add more light, it just kind of goes to hell. And then if I change the contrast and do all this other crap, it just keeps doing something. I just can't seem to get it to do much better than that, which is irritating. Anyway, all right, so we'll move on to the next comment. Right. Oh, wait a minute. So let me read the rest of this. You said you agree with Newton, but then you contradict yourself. So this is the part where I just want to block you. There's no contradictions. It's just a lie. It's just bullshit. You're the people contradicting yourself. You say momentum is a real thing, and then you just describe every way possible that it can't mean anything. It's a complete, it can do you no good to ever believe in momentum. If you were at all sincere to your belief in mv squared, because momentum isn't anything. For example, your prediction of what happens in the 3-to-1 collision is based on the idea that the sum is always conserved. Yeah, that's right, that motion is what's being conserved, the quantity of motion. That's how Newton understood it, as things carrying a quantity of motion. It's like a substance. All right, so the substance of the motion has to be conserved, and direction doesn't undo that. That's why fenders crush. They wouldn't crush if they didn't, if this stuff wasn't conserved. You know that if I made this the inelastic collision, with 1,000,000 miles and 1,000,000 miles, that I would crush the fuck out of them. Right? So if I had 150 momentums and 50 momentums crushing into each other, and they could crush fenders, they would crush 200 worth of fender. They wouldn't crush 100 worth of fender. And then you're just saying somehow in the elastic collision, no, I can get rid of 100 worth and only have to deal with 100 residue. So yours is the non-conservative argument. Regardless of directions, you predict quarter velocities after the collision because that concerns. Well, actually, in the 3-to-1, I don't predict the same velocities because I didn't realize that the double mass is the one that really has the same velocity, 1/3, 1/3. Because it's twice the mass, 2/3 goes one way, 1/3 goes the other way. But anyway. You predict quarter velocities after the collision because that conserves the sum of the quantities of motion, right? I'm always saying it's a substance. So yes, it's like radioactivity. It's like an amount of volume of water. It's like, what else? We can analogize it to it. The number of photons, it's pieces of styrofoam. It doesn't matter what you make it out of. I'm saying the force is a quantity, and it's in little clumps. You could just say Planck amounts of it. An electron amount of force, but it doesn't matter. It's in little clumps. It's in pieces, and the pieces are indestructible, as Feynman would say. Indestructible blocks, and they've always got to be somewhere. So you can't have a circumstance where there's blocks and there's blocks and all of a sudden I have no blocks. Nothing ever cancels. Okay, you can turn the steering wheel this way and then you can turn the steering wheel back that way, and be back where you started, but you can't cancel anything. All right. So yes, the quantity of motion you start with is the quantity of motion you have to finish with if you're not crushing something. All right, so that's my direct answer. That's always been the same direct answer forever. You predict quarter velocities after the collision. So again, the quarter velocity things, I'm not sure, no. It's not the same velocity leaving in both objects. Because that conserves the sum of the quantity of motion, right? But that breaks the rules of Newton and Huygens. They say you must subtract opposite directions. So again, they don't say the word you must subtract opposite directions. All they're saying is the difference between the two. So if I have 1,000,000 going in one way and 1,000,000 going in and 1,050,000 going in the other way, Newton's not saying that you can't have 1,000,000 going this way and 1,000,000 going that and 1,050,000 going that way now. He's just saying the difference, the 50, that's the difference, has to be the same. So again, it's your interpretation, okay, of what he's saying. He's saying if you take 1,000,000 going in and 1,050,000, and then you say, what's the difference between those two numbers, 50, and then you do it after the collision, you'll still have the 50. Now the problem is in the collision with the, two bodies coming together, where I would argue one has 75 momentums and one has 25, and they come together and 100 leaves. The two add, and the other one gets nothing. So clearly the difference, you could argue, between 75 and 25 is, a minus 25 and a plus 75 would be 100, right? So again, it just depends on how you read or how you interpret the concept of what a difference is. So if I'm allowed to start with negative numbers, well then yes, it's true, that you can create 100, that went in and 100 came out. And but anyway, these days the subtraction of opposite direction is built into the idea of momentum. Well, that's your business. I have no, so 1,000,000 goes in and 1,050,000 comes in the other way, and you say 50 comes out. So I'm just saying that's the implication of what you're saying. So do you believe that's the truth? Do you believe that's a fair interpretation of what you're saying? That I just subtract the numbers and now tell me what the total energy coming out is? Because that's what you're doing. You're saying I can actually have a car crash with 150 momentums and 50 momentums, and only 100 momentums pops out of the elastic car crash. I'm saying that's illogical. You can't destroy momentum. So that's why physicists like Lewin say that momentum is always conserved. Well, there's no point in saying nature can deal with kinetic energy one way or the other, implying that it's fudgeable, and then directly saying, but nature can't finagle momentum. No point in saying it can't finagle it if it can make it disappear. So if you can make something disappear, that's finagling. All right. So again, what's your argument? Simple scenario, right? I drew it, right? It's still there, right? In a piece of paper. It's still there. 1,000,000 going in this way. Let's see if we can see the red. Yeah, you can see the red. Good. And you have 1,050,000 going this way. All right. And you really think that when these two things collide, all that pops out is 50. That's it. 2,000,000 units of momentum disappear from the universe. So see, this is the problem with you people not being accountable. Where you don't make videos. I can't point out how, look, he evaded my point entirely. He didn't answer the question, blah, blah, blah. You have all this liberty to just ignore the direct statement. Do you think that would happen? Yeah. Do you think that's how it would work? All right. Okay. So that's why. Okay. So that's it for his comment. All right. Good. All right. So now we'll go to Elizabeth. Anyway, she's just. I don't know. It's like, I've made so many videos in this. I really hate having to tell people, just go to the fucking the videos, one of them. And, I make it pretty clear what I'm talking about. In my opinion, I'm damn clear. So I really don't see why you're having such trouble, getting it right. Understanding, I've been over it so many times. All right. Well, let me take a pause. All right. So Elizabeth starts. A question. If an electron is supposed to be constantly moving inside an atom, how do photons manage to hit the same electron if it has already changed places? Well, they wouldn't have to hit it more than once by their theory. Okay, it's not a frequency, that hits the electron. It's some magical part of the components of the photon itself somehow know they have a frequency, because the photon to them is one object. When obviously I would argue, yes, obviously it's not one object. So let's start with their wrong definition of the atom itself. And I've made it clear I don't believe their model. Okay, so their model is that you could have two nucleuses, net positive, and that an electron that's being shared, travels some wacky path, where it travels in orbitals around both atoms, and this is somehow sharing the electron. And I obviously, from just when I was a kid, I said no. I just, that seems very improbable as a mechanism that would hold something together. Very tightly, by the way. I mean, really hard to knock these atoms apart once they're bound, some of them. Because obviously the electron being way over here, there's every reason for this proton nucleus to just say, I'm leaving. Okay, I'm not interested anymore, because this is going to look net positive now. Without the electron in this location, this nucleus looks net positive. With the electron here, it looks negative. That's how each other sees each other, right? So if the electron is here, it sees the electron. That makes sense. I'm going to be attracted to it. I'm going to be connected to it. Likewise for this nucleus. But if I take the electron away and I put it some other place, then obviously these two nucleuses are going to see each other and say, I'm going home. I'm leaving. So to me, it doesn't make any sense. And the simple modification to that dopey theory is that no, nucleuses are net positive, okay? And electrons are locked in positions around that net positive. And because the nucleus itself is, yes, it's net positive, but it has parts of it that are electrons. There's electron-proton arrangement. So part of the nucleus looks negative from certain locations. So you can understand that the electrons have to position themselves where they're not too close to the other electrons, but they are very close to the proton. And that is what they see. They see the red. They don't see as much of the blue. And so they position themselves. And then the next ring of electrons positions itself away from these electrons, but it still sees the net positive of the nucleus. And so those are the energy levels, is the electrons piling on, because they always see a net positive nucleus. The nucleus from far away, the nucleus always looks net positive to an electron. Always. Okay. And it's only when it starts getting close that the net positive turns into a catch. Oh, you mean you have electrons also? Oh, puke. I don't like electrons. So they only, it matters how close you are to something. I put an electron and a proton in an environment, and then I put an electron in that environment. It's because of proximity, okay? It's not going to be balanced. It's going to be either very attracted or very repelled, based on where it's positioned. So how close you are to a nucleus will change what you see, okay? How blue and how purple and how red it is. Whether you're seeing red, purple, or blue depends on what part of the nucleus you're looking at and how close you are. So I made that clear that, yes, I think their orbiting model is junk, okay, not useful. And clearly what they're saying happens. Oh, I need a new piece of paper. Yeah, okay. I'm learning. Yeah, so, new piece of paper. Finding. All right. So I think what she's talking about is they draw these pictures like there's an atom, okay, and there's the electrons in energy levels, and they'll make some argument that the electron jumped from this energy level to this energy level, and a photon squiggled out. Okay. Now, that's just because they do everything based on what happens to a million atoms and what's produced. But yes, the argument is that photons can't be created by single electrons. That what's really happening is on a surface is that electricity travels. I should have drawn that in a different location. Just flip it over. Flip it over, Gary. Flip it over. Flip it over. There, that works. All right. I could. No, I can't. All right. So if you had a surface with atoms, okay, and these are the nucleuses, what a photon really is, all right, is electricity. And what electricity is atoms changing their shape. Okay, so as you push an electron in here, in this middle part, the electrons on the outside push out. Okay, So as the electricity moves through, it pushes the electrons out. And then, of course, they move back. So that's like, this one goes out, then this one goes out, then this one goes out, then this one goes out as it moves near the speed of light from atom to atom to atom. So it's pushing. The electron pushes here, pushes this electron, pushes this electron, pushes this electron. As it's compressing the atom this way, the atom's expanding this way, which means the electrons are being pushed out. And so that's what you're really doing, is causing a motion in the electrons on the outside, perpendicular, right? Perpendicular, so it's just completely consistent with creating a magnetic field in the sense that it's perpendicular to the electric field. So the electricity is moving this way, the pressure of electron pressure, and incidentally, by pushing the atoms, squeezing them this way, you've expanded them this way, right? And that's the trick of the whole thing, is that every time the electron pushes into the field, it creates a compression of frequency. Okay. And those compressions move through space. And so that's the polarization being created. So you're creating a compression in space that is a frequency between the rebounding. Okay, the force comes in at a certain rate, and you're compressing whatever comes in, and you're doing it in these parallel ways. So you're creating a field effect, okay, where you have, as I've drawn it many times, photons coming at different time intervals. So one of them, these are all parallel lines. So you have a clump of force, a clump of force, a clump of force, reflected force off the electron. Photons, compressed force, and you have these differences in time. So this polarization is proportional to the frequency. So that's the idea. So the idea is that a single electron is not making the photon. There's an electron over here and an electron over here. So in a stream of 500 atoms, these atoms are all creating the effect, and the byproduct of that effect is a photon that's going to have a dimension of 500 nanometers when the atom's only half a nanometer. So you can sort of get that the photon itself couldn't possibly hit an electron because it's really, really big. As much as it's really small, it's still really big compared to an atom. So it's made of discrete bits. It itself isn't. The photon is a pattern made of these bits. Okay, these bits make up the pattern. I've been over it so many times. Not very useful. All right. So next, let's see what it says. I don't know why this stays on the screen. It's always these little irritants. I got rid of you. Okay. All right. Even the fact that the photon hits it makes this electron change position. Right. So, see how to argue this one. The change in position requires there to be a change in the amount of energy, though. So you do have to be changing how the energy is hitting, how much energy is hitting a photon, or a photon's not going to be moving. So how much pressure there is over a period of time. Let's see. Yet they're elastic. So the fact is that if you take an electron from its position, it's in a field, and the field has a proton here and a proton here, and electrons are arranged, and it's found a position that's comfortable. And it might be wobbling in that position, but it likes that position. And if you push it out, then there's going to be a field change because you've moved it from its magnet, so to speak. So if it was a magnetic monopole, you could understand, once you've moved it, now you're creating more interest. Okay, because now it's going to want to move back to that position because it's further away from the electrons that were repelling it, that kind of thing. So it's going to try to move back closer to the proton again. So how can it hit a second time if it has already changed position? So yes, their understanding of frequency is you don't need time for a frequency to happen. It just somehow knows that when the little thing hits, it's 500 nanometer frequency, but it doesn't have to wait for the frequency. So that's obviously a silly notion of a photon, frankly, that somehow it's a clump and has written on it 500 nanometers, that it doesn't have any physical 500 nanometer property. It just writes it on it, 500 nanometers or 300 nanometers. And somehow it's on the clump itself. And that is ridiculous. It really is just about bullets. And the timing between the bullets is the photon. Maybe my question is stupid, but no one specifies that. Obviously, their theory is, try to explain it to you. You can shoot all kinds of holes in it. It's really bad theory. Okay, they haven't examined it, they haven't tested it, and they almost mock the idea of testing. Schrodinger's cat was a test, and look what they did to the test. They tried to convert it into some sort of real thing that, yes, cats can be dead and alive. Yeah, I mean, it's so silly, So there's not much you can say, Their arguments suck. Their theory is convoluted mush. And yes, simple things don't make any sense. How can a single electron create a photon? How does it do it? How does it create something with a polarization 1,000 times bigger than itself? Much more than 1,000 times bigger than itself. I mean, the atom is 1,000 times bigger. The electron is 1,000,000 times smaller than the photon. So how does something 1,000,000 times smaller than a photon create the photon pattern? I'd say, obviously, it cannot do it. It's silly. But they keep saying it anyway. All right. Yeah, so here's the other guy's comment. All right, so yeah, it was here. It's just that the order was different. Okay. All right. So that wasn't a mystery after all. All right, so I think that's it for comments and such. I guess I'll go check and see if there's anything of interest anywhere else, but doubtful. No, I couldn't find anything. Because of this YouTube glitch thing, I can't see my subscription. So if somebody, if there's a video out there that you think I might have been interested in, but I didn't see it or didn't notice it, or that's worthy of commenting on, if somebody makes a video on the subject or something, you could inform me. I'd appreciate it. Email or email address is always available, or comment and such. But seeing nothing, I will move on. Weather's improving, so I am my days are fuller of other projects. But anyway, till the next time and such.